Okay, let's find the Taylor series here. So I'll need some derivatives. F derivative, if you just think of this as 1 plus x to the power of minus 1, that'll be minus 1 plus x bring down the power, reduce the power by 1. Second derivative, that's going to be 2, 1 plus x to minus 3. Third derivative, that's going to be 6, 1 plus x to the minus 4. So it's looking like the nth derivative will equal n factorial 1 plus x to the minus n plus 1. So an, that's going to be f, and this is where the Taylor series is the sum of an. Maybe I shouldn't be using a. Oh, okay, yeah, I'll use a, and I'll say it's expanded at x0. Maybe I should change that to an x0. X minus x0 power n, and an is the nth derivative at x0 over n factorial, which, oh, and you know what? The signs are uh, alternating, so that's actually a minus 6. So what I also need here is a minus 1 with a power. Now let me see, evens are positives, odds are negatives. Okay, so if I sub that in there, the n factorials cancel. That's minus 1 power n, and then that's a 0. So, oh, just minus 1 power n. So this will equal the sum minus 1 power n xn, and n is going from 0 to infinity. By the way, if you write that out, that's 1 minus x plus x squared minus x cubed, etc. Okay, let's see what the convergence is. We'll calculate the limit as n goes to infinity, and we'll look at the ratio here of neighboring terms. If I call that the sum of bn, it's bn plus 1 over bn. So that would equal the limit as n goes to infinity. Minus 1 n plus 1 xn plus 1 over minus 1n xn. That is, because these are minus 1s or plus 1s, the absolute value of it is 1. So it's just going to be the absolute value of x. We need that to be less than 1, so that would mean that x should be between minus 1 and 1. But we should have to check what happens in the case of 1. So when x is 1, that would mean our series would be, if I was to just sub in 1, it'd be 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc. And when x is minus 1, s would be 1 plus 1 plus 1 plus 1, etc. Okay, clearly diverges in the minus 1 case. Now, you might be tempted to say that it converges in the first case here when x is 1, but this is actually an interesting one because depending on how you group things together, you can get different results. So if I group the second and the third, the fourth and the fifth, etc., those pairs cancel and I'll be left with 1. If I group the first and the second and the third and the fourth, and so on, they'll cancel. I'll be left with 0. So this is actually not defined. Um, so interestingly, here in both cases, we don't have a convergence. So therefore, the region is just the open interval from -1 to 1.